Hello, guys, and welcome back to another episode of chemistry. And of course, we thank God because this will be the last episode on our series of organic chemistry. Okay, so it has been a long ride, and if you have been joining us, thank you so very much. Okay, and today we're going to be looking at polymers as evidently written on the board. Do not forget that this tutorial is brought to you, of course, by the O3 School JAMB CBT practice app. Okay, it is all you need to succeed in your exam. Let's see a question that relates to polymers from the JAMB past questions that we have on O3 schools. This is 2015 number 11. It says the monomer of natural rubber. The monomer of natural rubber is A, 2-methyl-buta-1,3-diene. B says 1-butene 3-ine, C say buta-1,3-diene, D say 2-chloro-buta-1,3-diene. Okay, so these questions on polymers come out in your exams very well, so you cannot afford to joke with them. All right, so please ensure you download the O3 School JAMB CBT practice app and begin to study your way to success. Like we have said, the app has all you need to succeed. Okay, it has all the past questions, it has all the lecture notes for your exam. Okay, structured according to the JAMB syllabus, has wonderful features like, of course, the question search feature, just like the way we search for this question right now. Okay, and then we also have mock challenge on the app where you can compete with all students that are writing JAMB for this year. You compete against them to win prizes, to get it to JAMB past questions and likely exam questions, and to familiarize yourself with the format and the system in which JAMB is inserting what questions. Okay, so please do not sleep on the application. Download it and activate it. The price of activation is not up to the price of rice and chicken in a good restaurant. So please do not write JAMB twice because of of a small change. So please activate. The application is available for your Android phones, also available for your computer system or laptops at home if you want to practice so that I can have a clearer view and understand how the system works. Okay, you can download the software version. Okay, to download the software version, simply visit o3schools.com/JAMB app. Okay, and of course, if you need assistance about how to activate it on your laptop, just send a message to this number 091-215-15246. Okay, so if you need assistance with activating it, or you need assistance with downloading it on your laptop, just message that number. Okay, so today we're going to conclude our topic on organic chemistry. We're going to be looking at polymers. So what are polymers? These are the questions this is the first question that will come to mind. And the polymer is a large molecule. It's a large molecule. It's a large molecule that is composed of many smaller units. A polymer is a large molecule that is composed of many smaller units. Those smaller units are the ones we call monomers. We call those ones polymer. Okay, we call those smaller units monomers. Okay, while polymers are formed from this monomers. That means if you carry many small monomers together, okay, you can press them together like meshai, press them. What you go form now be polymer. Okay, so a polymer is gotten from a monomer. All right, so monomers, okay, they are the small units that make up polymers. That's why we say that a polymer is a large molecule that is made up of many smaller units, okay, that are known as monomers. Okay, so when we talk about polymers, we mean something that is very big, something that is very many. Okay, that's what polymers entails. Polymer is something that is very big, something that is very many. Okay, so those are polymers. Of course, during polymerization, what happens is that the smaller units, okay, will come together, and then it will now form the bigger unit. This polymer. So for example, let's say we have an equation, okay, A is equals to A plus B plus C. Okay, so let's say these ones are monomers. This one is polymer. What this equation is simply telling you is that when you add all of these small units together, let us say plus D plus E plus H. Okay, once you add all of these units together, okay, what it gives to us is this A. Okay, that means that in this case, All these ones, they are the monomers, while these ones are the what? Are the polymers, okay? So, and of course, we'll talk about it in a moment. The polymers, the monomers rather, may be what? They may be identical or they may be what? They may be different. So it is what? It is okay like that. So this is, in this example now, in this illustration, this will be the polymer, while this ones will be what? The monomers. Okay, so it is good to understand that what the polymers, okay, they are large, they are big molecules, okay, that are gotten from smaller units. From smaller units that we call what? Monomers. Okay, so take note of that. Therefore, the process whereby what? These smaller units come together to form what? These polymers is what we now call what? Polymerization. Okay, I'm sure you must have heard about polymerization what? Before. Okay, it is what? The bringing together of what? Of smaller units, okay, to form a larger unit that's called what? Polymers. Okay, bringing together of what? Of smaller units known as monomers together to form what? Something as large as what? As polymers. Okay, so please take note of that. And there are so many you should also know that what? That these polymers, they can be made up of hundreds of thousands of monomers. They can be made of millions of monomers. Okay, so take note of what? Of that. Now, there are somewhat polymers that you might have encountered. Okay, there are some natural polymers that you might have what? Encountered what? Even before now. Okay, we know them very well. For example, we have what? Your DNA. Your DNA is what? Is a natural polymer. It's a natural polymer. Your DNA. You know what DNA is, right? Deoxyribonucleic acid. Okay, deoxyribonucleic acid. Biology student. Okay, that's what the meaning of what? Of your DNA. Okay, so your DNA is made up of what? Of nucleotides. What? Monomers. Okay, your DNA, the deoxyribonucleic acid, is made up of what? Nucleotide what? Monomers. Also, your proteins. Protein is another type of what? Natural what? Polymer that we have. Proteins. Okay, there's another example of what? Natural polymers that we have. Of course, proteins are made up of what? Of amino acid monomers. Okay, proteins are made up of amino acid monomers. Likewise, we also have polysaccharides. Polysaccharides like starch and cellulose. Okay, polysaccharides. Okay, like what? Like starch and cellulose. Okay, these two, they are what? They are polysaccharides. They are made up of what? Of monomers of what? Of glucose. They are made up of monomers of what? Of glucose. Okay, all these are what? What do you call them? Call them what? Polymers. They are all what? Polymers. They are natural polymers that we encounter what? In daily life. Okay, so but in organic chemistry, one of the monomer that we encounter very, very well is what? Is ethylene. Okay, one of the monomer that we will encounter very, very well is what? Is ethylene. Okay, or what? Ethene. Same thing as what? As ethylene. Okay, so this is one of the monomer that we will encounter very, very well when it comes to what? Organic what? Chemistry. And the polymerization of what? Of ethene, okay, or what? Ethylene gives us what we call what? Polyethene. The polymerization of ethylene gives us what now? Polyethene. All right, polyethene. All right, this is what your ethene. The monomer is what? Ethene. That is CH2 bonded to what? To C what? H2. Okay, so this is what one of the what? This is one of the what? Most what? Common monomers that you encounter when it comes to what? Organic chemistry. So take note of that. It is very, 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 very important. So later on, we'll see more about what? Polymers and monomers. As you can see, that all be stated what? On the board, just for you, so that I can have the notes. You can what? Go over them and over them and over them and understand them, because these questions are repeated. They come out very well in your exams. That's why we do not want to leave any stone unturned. Okay, so now polymerization can be by addition or condensation. Polymerization can be by addition or condensation. Okay, polymerization can be by addition or condensation. And when it comes to condensation polymerization, all right, we have what? Two types of what? Polymerization we discuss. One is what? Homopolymers. Homopolymers. Okay, and the other one is what? Is copolymers. Copolymers. All right, take note of that. So I said, let me go over that again. I said polymerization can either be what? By addition or what? Condensation. Okay, so we can have addition polymerization, and we can also have what? Condensation polymerization. And when I talk about what? Condensation what? Polymerization, we talk about two types of what? Polymerization. That's what? Homopolymers and what? B copolymers. These are the two types of polymers we have under condensation polymerization. What is homopolymers? By homo, okay, it means that what? That the monomers that are making up the polymers are what? Are the same or they are identical. Okay, so homopolymers are homopolymers are what? Are polymers that are what? That are made for what? For identical monomers. Homopolymers are polymers that are made from identical what? Identical monomers. While copolymers are polymers that are made, okay, from what? From different. Okay, they are not identical, they are different. The monomers that are making those polymers, they are not what? They are not identical. That is what for copolymers. While for homopolymers, they are what? They are identical. Please take note of that also. So polymerization is by either by addition or by condensation, and by condensation is by homopolymers. There can be what? Homopolymers or what? Copolymers. Take note of that. It is very, very important. All right. So likewise, in addition polymerization, the monomers join without loss of any atom or group. In addition polymerization, the monomers, they join without loss of any group or atom, without loss of any atom or group. For addition polymerization, the monomers, they join together without loss. If you are taking note, please take the notes, okay? So in addition polymerization, the monomers, they join together without loss of any atom or group, without loss of any atom or group. Okay, why for condensation polymerization, okay, for condensation polymerization, the monomers join with what? With loss, okay, of a small atom or group. Okay, this one is with loss. The monomers, they join with loss of a small atom or what? Or group. Take note of that. So see the difference between addition polymerization and condensation or polymerization. So we say in addition polymerization, the monomers, they join without loss of any atom or group, while for condensation polymerization, the monomers, they join with loss of a small atom or group. Take note of what? Of that. All right. Now there are examples of what? Addition polymerization. Examples of addition polymers. Okay, polymers that what? Undergo what? Addition polymerization are what? One is what? Polyethylene. Polyethylene or polyethylene. Polyethylene or polyethylene is what? It's an example of addition polymerization. Okay, even polyphenylethene, that is polystyrene, okay, is also an example of addition polymerization. Then likewise, perspex. Perspex is also what? Another example of what? Of addition polymerization. Okay, while for condensation polymerization, okay, we have example is nylon 66. This nylon 66 is an example of what? Of condensation polymerization. Terylene is an example of what? Of condensation polymerization. Please take note of what? Of those examples. Okay. Now, it is also worthy of note to note that what? That polymers may be natural or synthetic. Polymers, these polymers we are discussing today, they may be natural, okay, or they may be what? Or they may be synthetic. Okay, polymers may be natural or synthetic. Take note of that. Polymers may be natural or synthetic. Example of natural polymers include examples like resins. Resins are natural polymers. Your natural rubber is an example of a natural polymer. Okay, then your starch is also an example. Your cellulose is an example. Your protein. Okay, all these ones are examples of what? Of natural what? Polymers. Okay, we say polymers can be natural or what? They can be what? Synthetic. Okay, examples of natural are resins, natural rubber, starch, cellulose, and protein. Okay, while examples of synthetic, of course, synthetic, they may be what? thermoplastic or thermosets. Okay, for synthetic, there may be what? Thermoplastic or what? Or thermoset. Take note of that. Okay, so synthetic polymers themselves, they are known as plastics. Synthetic polymers are known as what? Plastic. So you can also call them what? Plastics. Okay, synthetic polymers are known as what? As plastic, and they may be what now? Thermoset or thermoplast. Thermoplasts, thermoplastics or what? Or thermosets. Okay, so synthetic polymers are known as what? Plastic, and they may be either what? Thermoplastics or what? Or thermosets. Okay, thermoplastics or what? Or thermosets. Take note of that. Now, what is the difference between thermoplastics and thermosets? Thermoplastics, they can be heated, they can be what? Molded. Okay, so they can be heated and they can what? They can be molded. But of course, thermosets cannot be what? They cannot be heated or melted by heating. They cannot be melted by heating. So for a thermoplast, okay, you could heat it, you could what? You could melt it, you could even mold it. For thermoplasts, you could what? Heat it, you could melt it, you could mold it. But for thermoset, you cannot what? Melt it by what? By heating it. Okay, that's the difference between what? Thermoplastics and what? Thermosets. So examples of thermoplastics and thermosets are the ones that we all have here on the board today. Okay, and they are exam questions. These are questions that come out in your exam a lot. So please, you should not what? Sleep on them at all. Okay, so examples of what? Of polymers, okay, and their monomers. Monomers, they are the repeating units, okay? These are the smaller units that make up what? These polymers. So now, the example number one is what? Is polyethylene. Polyethylene is also called polyethylene, okay? And of course, it's what? The monomer is what? Is ethene. It is made from what? From ethene or what? Ethylene. Take note of what? Of that. Then number two, we have polyvinyl chloride, what we call PVC. Okay, it's made from what? From chloroethene, which is also what? Called vinyl chloride. So you should know all of these. Then number three is what? Polyphenyl ethene, which is called polystyrene. Okay, polyphenyl ethene is called what? Polystyrene. All right, and of course, the monomer is what? Polyethylene, which is also called what? Styrene. Then number four is perspex. Okay, and perspex is what? Is methyl 2-methylpropanoate. Okay, that is what? That is the name. That is the common name. Methyl 2-methylpropanoate. Okay, that is what? The monomer of what? Of perspex. All right. Then number five, polyacrylon nitrile. Polyacrylon nitrile. Okay, and the monomer is what? Is acrylon what? Nitrile. Okay, so this is simple unit that what? That make up what? This polyacrylon what? Nitrile. Now, nylon 6,6. Nylon 6,6 has what? Two what? Different what? Monomers. It's made from what? From two different what? Monomers. One is what? Is hexamethylene diamine. Hexamethylene diamine and adipic acid. Adipic acid. This adipic acid is also called hexane dioic acid. It's also called what? Hexane dioic acid. So adipic acid and what? And hexamethylene diamine. All right. These are the monomers that make up of this nylon 6,6. Now we have what? Terylene. Terylene is made from what? Monomers of what? Benzene 1,4-dicarboxylic acid and ethane 1,2-diol. Okay, benzene 1,4-dicarboxylic acid and ethane 1,2-diol. All right. Then number 8, we have phenol methanol, which is also called bakelite. Bakelite is made from phenol, which is called hydroxybenzene. We know phenol, right? When we did benzene derivatives, we saw hydroxybenzene. That is our phenol. And what? Methanol, okay? It's what? It's a copolymer, all right? A nylon is also what? A copolymer. It's made from what? From two different polymers, so from two different monomers. Then benzene, terylene also is also what? A copolymer, because it is made from what? From two different what? Monomers. Now, number 9 is natural rubber. This one comes out in your exam very well. Or the one we call isoprene rubber. You see from the past question in the moment, natural rubber or the one we call isoprene rubber, okay, is 2-methylbutyl-1,3-diene, which is what? Your isoprene, okay? That is the monomer that makes up what? Your isoprene rubber. Now, number 10, synthetic rubber is called what? Neoprene, okay? And the monomer that makes it is what? Is 2-chlorobutyl-1,3-diene, which is what? Neoprene. It's called what? Neoprene. So do not confuse isoprene and neoprene, all right? Now, number 11, which is the last one, is styrene butadiene rubber. Styrene butadiene rubber, as you can see, is also what? A copolymer. Okay, it's made from phenylethene and butyl-1,3-diene in the ratio 1:3. So it's like 25% 25% ratio 75 what percent. So 25% of phenyl 18 and 75% of buta-1,3-diene. So the ratio is what? Is 1:3. 25 can go into 75 3 times. So 1:3. Okay. So we prepare what? Styrene butadiene rubber. I'm stressing this because you see it in your exam. Okay, it's in your exam past questions. Okay, so now styrene butadiene rubber is made from monomers of phenyl 18 and buta-1,3-diene in the ratio 1:3. Take note, if I was an examiner, that's the kind of technical question I will ask you. So please do not fade up. Do not fade it. Now let us go to our past questions and answer the questions that we have from this application that was searched using the question search feature. All right, so please download the application. You have nothing to worry about. Now, this is a 2015 question number 11. It says, the monomer of natural rubber is natural rubber. The monomer of what? Of natural rubber is what? Is isoprene, okay? Which is what? 2-methyl-buta-1,3-diene. So being you say they know the answer. The answer. Okay? Natural rubber is isoprene rubber. And the monomer unit is what? 2-methyl-buta-1,3-diene or isoprene. So A say 2-methyl-buta-1,3-diene. Very correct. B say 1-butene-3-ine. C say buta-1,3-diene. D say 2-chloro-buta-1,3-diene. Correct answer is what? Is option A, 2-methyl-buta-1,3-diene. Okay. 2014 number 45 now, being displayed on your screen right now. They say the polymer used in making carrier light. Carrier light is perspex. We use perspex in making what? Carrier light. I'm sorry I did not add many of the uses. Okay, but please look up on those one. Okay, pretty master T small. Okay, so perspex is used in making what? Carrier light. It's used in making carrier light. A says bakelite. B say polystyrene. C say polyacrylon nitrile. D say perspex. Okay, D is very correct. Perspex is used in making what? Carrier light, because it's what? It is resistant, okay, to water. All right, and let us see another question. 2020 number 38. 2020 number 38. They said the repeating unit in natural rubber. Where's natural rubber? Okay, the same natural rubber again. Is what? Is isoprene. A say alkyne, B say isoprene. You see, later you say JAMB does not repeat past question. Okay, JAMB does repeat what? Past questions. They do. All right, and this is a what? This is a good word case. All right. So in the first example you saw, okay, they asked you now the repeating unit. Let me go back to that question. The monomer. This time they asked you the monomer of natural rubber is. But they give you this name 2-methyl-buta-1,3-diene. All right. But in the other question now that we have, they are giving that the repeating unit in natural rubber is, but we are not giving the common name. Okay. We are giving what? We are giving what? This one is the common name. This one is what? Is the IUPAC name. Okay. So you are giving what? This time now we are giving what? The common name, isoprene. So they repeat past question. Now you know one serious. So please be serious. Okay. Stay glued to your studies. Now, 2002 number 40. It says, which of the following polymers is suitable for packaging and electrical installation? Okay, I said electrical was insulation. Okay, and that will be polystyrene. Okay, where's polystyrene? Where's polystyrene? Polystyrene. Okay, that is what number 3. That's polyphenylethene. Okay, it is useful for what? For insulation. Okay, for packaging and what? An electrical insulation. Take note of that. All right. So there are so many other questions on this application. Okay, that has to do with this. So go and download the app. Go and use your question search feature, study the lecture note, and what? Be prepared for your exam. Okay, pass your exam once and for all, and you see yourself smiling. My name is Master T. I'm the Grand Commander of the O3 Schools Army. Thank you for joining us. All right, we'll see you at the top.